Hello and welcome to the Program Design and Evaluation course. This is Saltanat Liebert at VCU, and today's lecture will focus on the design of the evaluation. In preparation for an evaluation, in order to determine the appropriate design, an evaluator needs to decide which people or units should be studied to best gauge the effectiveness of a program. An evaluator needs to decide about sampling techniques as well. If the unit of analysis is program participants, how will they get selected for the evaluation? If the program is not very large, every single participant can be surveyed or otherwise studied. If the program is large, though, and there are hundreds or thousands of participants, the evaluator needs to decide whether to use convenience sampling, selecting informants informally, or whether to use systematic sampling. Systematic sampling is almost always preferred and adds methodological rigor to the evaluation. The types of comparisons and evaluations include comparison of outcomes for treatment group and control group, the so-called gold standard in evaluation. Or if there is no control group, the situation of program participants before and after the program could be compared. Or instead of a control group, a comparison group could be selected to compare the program participants to those in the comparison group. The timing of data collection depends on when the evaluator has access to program participants and to program staff. If the evaluator is brought on board before the program began, data should be collected on program participants before the start of the program. Then data should also be collected at logical points throughout the evaluation and after the completion of the program. In many cases, it is appropriate and preferable to collect data after the program has concluded to be able to gauge whether program outcomes are sustainable or whether they fade shortly after the program is completed. Evaluation can focus on program process or implementation or on program outcomes. Comprehensive evaluations typically look at both. Process evaluation usually has a less formal design than outcome evaluation. Data collection methods for an evaluation could be quantitative or qualitative. Increasingly, mixed method evaluations, which rely both on quantitative and qualitative methods, are becoming popular. In some cases, a qualitative approach to process evaluation is appropriate. Such situations include cases when the evaluator has limited knowledge about the program and its activities. When the program is novel, new, and it differs from how similar programs were implemented in the past, that might be the case when it's appropriate to use qualitative methods. Another case when qualitative methods are appropriate is when the program theory is either not clearly articulated or it is problematic. One instrument for data collection on program implementation is to develop a form that program staff would regularly fill out. This would allow the evaluator to gauge what the program does on a daily basis. Another approach to process evaluation is to survey or interview program staff or program participants about the program. Every evaluation design has strengths and weaknesses, and the job of the evaluator is to select the most optimal design given the circumstances. Most problems with an evaluation design have to do with internal or external validity. Validity is the extent to which the indicator measures what it's supposed to measure. There are three types of internal validity: content validity, construct validity, and criterion validity. Content validity is the extent to which a measure represents all aspects of a social construct. For example, in education, this could be the extent to which a test adequately represents the subject matter content or behavior that's being measured. Construct validity is met when the relationship between independent and dependent variables is logical. For example, researchers have noticed that when ice cream sales go up, so does the rate of violent crime. The relationship between ice cream sales and the rates of crime is not logical. The relevant variable in this relationship is weather. Warm weather impacts both the ice cream sales and the rates of criminality. Criterion validity is the extent to which a measure is related to an outcome. For example, do SAT scores predict academic success in college? This has been the question of debate for quite some time now. External validity has to do with whether the findings of the evaluation are generalizable to other similar programs. Research designs that have high internal validity are often not generalizable, and vice versa. Evaluation designs can be formal and informal. Informal evaluations include self-evaluation and expert judgment. They are considered less credible than formal evaluations that follow the social science research protocols. Formal evaluations include randomized experiments and one-group designs. The gold standard in program evaluation design is a randomized experiment. Randomized refers to study participants being assigned to program group or control group randomly. This type of design has the highest level of internal validity, meaning that it is best positioned to prove causality that program intervention leads to observed outcomes. However, it has low level of external validity, meaning that results would be hard to generalize to other populations, because under experimental design, program participants get sort of a hothouse treatment, which would be hard to replicate in real life. In an experimental design, there are at least two groups, one group that receives program services and the other that does not. There could be another group that receives different services which are intended to achieve the same outcome, so this group could be added for comparison purposes. These groups are compared before the program and after its completion. It's also a good idea to collect data during the program to gauge interim progress. In one-group design, there is no control group. After only one-group design becomes a default design when the evaluator is brought on board, not from the beginning, but after the program has been completed. So the evaluator is only able to collect data on program participants after the program, not before. In a before and after design, the evaluator is able to collect relevant data from program participants before the program has begun and after its completion. There is still no control group, so this type of an evaluation design is often viewed as not being authoritative enough to render judgment on the effectiveness of the program. If the evaluator wasn't on board before program began, and thus couldn't collect data on program participants before the program, the options for the evaluation design are limited. One of these options is the after-only design. When an evaluator is faced with after-only design being the only feasible choice, she can make assumptions about what program participants were like before the program. This could be done through a review of program records, conducting historical comparisons, asking program participants about their relevant conditions before receiving program services. An evaluator can also use her expert judgment based on the knowledge of similar programs. As you can imagine, though, this is not really viewed as an empirical method and would leave stakeholders skeptical. And finally, new program participants could be used to gauge what current program participants were like before receiving services. One-group designs have some strength, but also substantial weaknesses. They cannot fully prove that the program outcomes are due to the program or due to other external factors because there is no control group. One-group design can provide a preliminary look at the effectiveness of the program. For example, if we're looking at a program to help people stop smoking, And we find that 95% of program participants did indeed stop smoking. This suggests that the program was effective. Because there is no control group, though, we cannot prove causality definitively. We cannot prove that the program indeed resulted in smoking cessation, as opposed to maybe there was a new public service announcement series that aired on television at the same time as the program, and that actually led to increased numbers of people quitting smoking. Unfortunately, one group design is often the only option because evaluations are conducted after the program has been completed. There are, however, ways to enhance and improve the one-group design. One-group design can be enhanced in three ways: collecting more data during the program, collecting more data on what happens well before and well after the program through a time series analysis, and through adding a comparison group. One of the ways to improve the one-group design is to collect more data during the program. This includes a dose-response design, when program participants who receive a larger quantity of services are compared to those who received less services. Using the example of reading intervention for elementary school-aged kids, we would compare those who received weekly tutoring to those who received daily tutoring, with the assumption that daily tutoring helps improve reading skills more than weekly tutoring does. We can also compare alternative kinds of service, such as small group tutoring to individual tutoring. The second way to improve the one-group design is to use the time series design. This would involve collecting data before the program begins and continue periodic data collection after the program is completed. The example on this slide shows that the behavior of program participants changed after the program and that the effects were sustained over time. In this example, the program was administered between the months 3 and 4, which are delineated by red lines. The red lines on the slide, by the way, are not straight, simply because my drawing skills are sadly rather deficient, so it's not by design that the lines are not straight. In this example, the data were collected for 2 months before the program began and for 6 months after the program was completed. This chart provides some evidence that the program was effective and that the results were sustained over time. One-group design can also be improved by adding a comparison group. This would involve adding another group to the study of individuals who did not participate in the program, but who are similar in their makeup to program participants. Adding a comparison group improves internal validity of the evaluation. Evaluator compares status of program participants and the comparison group before the program begins and tests how similar they are in age, socioeconomic status, or other relevant factors. Initial differences between the two groups, such as self-selection or motivation, have to be taken into account in the analysis and reporting of the findings. To create a comparison group, an evaluator could individually match non-participants to participants based on all factors that could impact the outcome. An evaluator could also create an artificial comparison group by using available datasets. For example, if we want to gauge the impact of a pre-K program, we could use the assessment of the teacher's rating of their school readiness when children start kindergarten. We can then sort this data by whether or not the kindergartners attended pre-K. This will give us an idea about the effectiveness of pre-K programs. However, selection bias is a threat to internal validity in this scenario because parents who choose to enroll their children in pre-K might be qualitatively different from those who do not, which could impact school readiness skills of their children. There are statistical tools that can be used to equate participants to the comparison group. These tools include forecasting the situation without the program, statistical adjustment for pre-existing differences, and modeling the selection process. If you would like to learn more about these tools, I've posted a book chapter in the course readings. This is the end of the lecture on evaluation design. Thank you for listening and take care.